So you guys had 160 and 130. Hang on, 160 and 130. Why is that not updating? There we go. Oh, you can't see that. Sorry. Boom! There's your graphs. 160, there's 130, right there. So, in other words, Carrie's concern is it's never going to hit 0, is it? What's cool about this is not linear modeling. This is not quadratic modeling. This is not exponential modeling. This is not logistic modeling. This is what's called uniform modeling. Don't memorize that. Not important right now. But thank you for bringing it up. Theoretically speaking, how big should these bars be with respect to each other? I have a vote for about the same. A vote for yeah. Or a vote for agreement. A vote for yeah. A vote for yeah. A vote for agreement. I second that, Joanne. Thank you. So, Taryn, why would you think they should be about the same? Why is it 50-50? That's one coin, not two. Prove it to me. I love this. Oh, we just did, dude. Check this out. Check this out. I like what I'm hearing over here. I'm going to turn this off. Those bars, I agree, should be the same height. Theoretically speaking, not exactly in data, just like all data is noisy. Remember how we said the only way you can be in this is if you went heads, heads, or tails, tails? Well, the only way you can be here is if your first flips were what? Heads, tails, or tails, heads. The third flip really is irrelevant, isn't it? Once you flipped either heads, tails, or tails, heads, whatever you flip next, you're done. Is that fair? You're done at that point. So, heads, heads, tails, tails put you here. Heads, tails, tails, heads put you here. If you guys have looked at your project for Wednesday already, you know that these are just as likely as this, based on tree diagrams. First flip, heads or tails. At this point, all's possible. Half the time, off of the first flip, half the time the second flip matches it, and half the time it doesn't match it. Off the first flip, half the time it doesn't match it, half the time it does match it. So half the time, the two flips match each other, and half the time they don't. So yeah, those bars should be exactly the same height, in other words, uniformly tall. Which means the perfect average number of flips should be how many? If these frequencies were exactly the same, what would the exact average number of flips be? Not 2.45, but 2.5 exactly, wouldn't it be? Ours is 2.45 because our data showed a few more of these than these. Yeah, a few more 2s than 3s. So our average is a little bit low. Suppose this was 160 and 160. 160, 160? That would be 320 down here. Yes? And the numbers would then change. Be 320 down below, and it would be exactly 2.5 times that up the top. Half the time. In other words, think about it this way. Don't overthink this. If we saw exactly the same heights of bars in that graph, half the time we'd see 2s, and half the time we'd see 3s. That means half the families in America have 2 kids, half the families in America have 3 kids. In other words, on average, they have 2.5 kids. That's all we're saying here. But you don't have to memorize that. All you've got to know is how to apply a weighted average. All you've got to know is how to apply a weighted average. Is that believable? Does that make sense? Okay, that's all. That's it. That weighted average, this will take you so far in understanding how your life is put together. Honest to God, we're going to keep it pretty simple with cards and coins and dice and things like that in here. But in 243, I had the kids just recently showing how if you pay close attention, well, we'll get to that. We'll get to that next class. Here's what I want you to do for next class. If you have the time to, you know what? You don't have the time to do it. You have a project to do. Let's do it in class next time. Forget this. I was going to have you do it for homework between now and then. That's dumb. You got 2 quizzes and a project. You'll be busy. We'll do it in class next time. We're going to go back to Chloe's question. We don't have time right now. We can't do it in 5 minutes. Taryn. So you're saying 2 plus 3 divided by 2. That, yes, for a uniform distribution, which they're not always uniform. That's the thing. For this particular one, I wasn't even going to go there. Thank you, Karen, for taking us there. It was kind of fun. I appreciate it. I do. I appreciate it. It's great. But for a uniform distribution, yes, like rolling 1 die, the average roll is 3.5 because 1 plus 6 is 7 divided by 2. But that only works if the graphs are perfectly uniform. So we'll see more like that. We'll also see ones more not like that. Cool? Okay, we'll catch you guys on Wednesday. Just drop the coins back up here if you don't mind. We'll flip them again on Wednesday.